Welcome to the Mahatma Gandhi Institute of Technical Education and Research Center. In 2004, a national level institute MGITER has been started in the field of engineering and technology as per guidelines of All India Council for Technical Education AICTE New Delhi. MGITER is approved by AICTE New Delhi, Gujarat State and affiliated to Gujarat Technological University Ahmedabad, which is also known as GTU. Our goal is to be an institute of generative ideas so that we remain relevant to our society. The MGITER has always been an organization on move with continuous effort on improving its processes and to maintain its relevance to the Indian science scenario, with adding new programs in its programmatic portfolio. We strongly believe in overall development of students, so for that we provide them a different platform like state level tech fest, project fair, different sports activity, which helps students to teach teamwork and problem solving skills to get physical health benefits, boost self esteem, and reduce pressure and stress for prove their skills in distinct area. Welcome to the virtual class of Power System Transients. Myself, Professor Gaurang Patel from Mahatma Gandhi Institute of Technical Education and Research Center, Navsari. So today we are going to discussion of the chapter number 2, that is traveling waves on transmission lines. Okay, so basically in this chapter we will start with the introduction, what is traveling waves, then we discuss what are the circuit with distributed constants, then the wave equation, and we also discuss regarding the reflection and refraction of traveling waves that was so asked so many times in GTO examination. Then we see the behavior of traveling waves at line termination, then Beverly lattice diagrams, then attenuation and distortion of traveling waves. Okay, so such kind of topics are covered during this session. It may be parted with section 1, section 2, etc., as per our conveniency. So let's begin with the first topic. Okay, so these are the mainly contents which I like to cover during this lecture session. We can see here in this PPT, that is, first of all we will start with the introduction of traveling waves, then we will move towards the circuit with distributed constants, and well, when this lecture is going on we will cover one by one this topic. This is the wave equation that we have to establish from the circuit with distributed constant. Then we see what are the effects of reflection and refraction of traveling waves, and what are the constants of refraction and refraction when line is open circuited and line is short circuited. Okay, so let's begin with the introduction of traveling waves. Okay, so we will start with the definition of traveling wave. So we see what the definition is showed us to here. The definition says that traveling wave is a temporary wave, okay, that creates a disturbance and moves along the transmission line at a constant speed. Okay, now it is considered as a disturbance wave, and it is having also two more properties. One is known as, I would like to say, one is the attenuation, and second, that is the distortion. Okay, so and another thing, it says that such type of wave occurs for a short duration. That is, we know that it is a kind of transient wave, and transient, it means itself, it is about the short duration. So mainly what is the attenuation and distortion in traveling wave? In vivas, there are so many times they are asked for this question, that is, what is the attenuation? Okay, so you can define that attenuation as as a traveling wave moves along a line, it suffers both attenuation and distortion. Now we can focus on attenuation. At the time we define the attenuation, we can say that the decrease in the magnitude of wave as it propagates along the line. Okay, the decrease of magnitude of that particular wave when it is propagates, that means when it is traveled along the line, is called the attenuation. Means the value, if the magnitude value is increased during its travel, that is known as attenuation. And for the distortion, we can see that the elongation or change of wave shape that occurs is called distortion. So due to this traveling wave, if the wave shape of main power, that is voltage and current, if it is disturbed or it is going to be changed, at that time this phenomenon is known as the distortion. So I hope you will aware about these two things when traveling wave comes into the picture, that is attenuation and distortion. Okay, now if we moving forward to discuss in detail what is traveling wave is that, so first of all we have to consider a transmission line. Okay, so we know that whenever we want to send an electrical signal, we need two wires. Okay, you can see in this diagrams, that is we need two wires over here, okay, to send the electrical signals. Okay, so whenever two metal conductors are comes into the picture, there is an inherent property, that is it makes some capacitance. Okay, the definition of capacitor itself, it says there is two metal plate is separated with such a distance. Then whenever this type of situation is occur, it is establish some capacitance between two lines. Okay, and whenever we need to an electrical signal, there is two conductors we need. Over here we consider there is two lines or two conductors that carries our electrical signal. Okay, so we can say that when our transmission line carries the signal, it is what we can say, it is their inherent property that it will create a capacitance in between them. Okay, so when we okay, so as per our discussion, when two metal conductors are there, it creates a capacitance, and similarly it is having some inductance as well in every transmission line, because it's a kind of formation of loop. We can see over here in this diagram, there is some of the inductance present over there, and some of the capacitance is always remain present over there, and there are the different sections it has been created for our understanding, because there are number of transmission line is connected together, because our electric system is an integrated power system. Okay, so there are number of transmission line is connected together, and there is a number of section which is having such kind of inductance and such kind of capacitance. Okay, so now what is the story? Then whenever we switch on the supply, or if we switch on the supply between, if I will connect one source in between these two conductors, so what happened, whatever the supply we give to this transmission line, we think that it will travels instantaneously towards the load. Suppose there is one load is present at the end of this transmission line. So just a moment. So we think that this, whatever the supply we given, that is reached over to this load instantaneously, but no, it is not happen like that. Okay, why? Because there are some inductance and capacitance comes into the picture. So whenever we switch on the supply, the first of all, this section inductance and capacitance is going to be charged. Okay, section inductance and capacitance means if the supply is going through this. So first inductance comes into the picture is there, it will be going to charge with some value, then this capacitor is going to be charged with some value, then after this wave or this power is transferred to the another section, and then this part will be charged and then this capacitor will be charged, and then this power moves to the another section. So it is happen like that, it is a repetitive action. So it is not like that when we switch on the supply and power is immediately or instantaneously comes to move or forwards to the load, but it is not like that, because there is an inherent property of transmission line, that is some inductance and capacitance is always present in the transmission line, and we are not deliberately connect those equipments in this transmission line, but it's their inherent properties. Okay, so it takes some time, it takes some delay when we switch on the supply and the supply is travels toward the this load, and in between that there are some phenomenon occurs, there are some things are happen, some parameters are there that we have to discuss in this lecture. What are the effects of those parameters, how it will occurs, what are the properties of it, and what equation can be formed to solve those things. Okay, that we discuss in this lecture in detail. Okay, so now if we can see that when electric circuits appear to behave in unpredictable ways that seem to violate the laws of physics, this is often due to capacitance and the inductance of the wires. Okay, and in this instance, for example, the signal keeps bouncing back and forth between the beginning and the end of the transmission line, that is from the beginning, just a moment, so that is from the beginning and from the end it is bounce back through the transmission line. Now with knotting connected to the end of the line, the voltage at the end of transmission line reaches double the value of the input voltage. Now when it's happened, the value of the voltage is becomes doubles whatever the magnitudes we apply inside input. How it will come, I will show you later in this video lecture. Okay, now then the signal is reflected back, as we saw this signal is reflected back from the transmission line. Okay, now reflection can also occurs at the connection between two transmission line. Now if the now there are, as we discussed, there are a number of transmission line is connected in interconnected system. So definitely there is a reflection comes into the picture in between these two transmission, in between these two transmission lines. Okay, and why it is happen, because if in which case only a portion of the signal is energy is transmitted to the next line and the rest of energy is reflected back. Okay, now suppose we connect a short circuit end of transmission line, that I will show you. Suppose we connect, this is the end of the transmission line and it is connect with this short circuited line. Okay, now suppose we connect a short circuit at end of transmission line, what will happen? Okay, what will happen if we getting to be it's short circuited? At that time this signal reaches this short circuit. Okay, those signals are reaches at short circuit. So what happens? As always, the speed with which a signal travels depends on the capacitance and inductance of that particular transmission line. So whatever the speed of that wave, that is depends on the value of this inductance and value of this capacitance. Okay, so when the signal reaches the short circuit, the signal is reflected, but with the voltage flips upside down. That means voltage is flipped. That is, and it happens on what? It happens on what I will say. It happens on the impedance what we connected at the end of the transmission line. So suppose I will talking about this. If I connect a such value of an impedance, it depends on that how this voltage is going to be reflected back and how it is going to be flipped over there. Okay, so again I discussed that suppose we connect a short circuit at the end of transmission line, it is going to depends what amount of impedance it will be get into its way. Okay, so when the signal reaches the short circuit, the signal is reflected but with the voltage flip upside down. Now it will behave like a short circuit, and if the impedance is too high, it will behave like an open circuit. Okay, if there is an impedance is too high over there, if impedance is too high at that particular portion, it behave like an open circuit. Okay, and its impedance is too low, it's behave like a short circuit. In both of the case there is going to be a reflection, but if we place just the right amount of impedance to avoid these things, if we place just the right amount of impedance over here, so we can avoid this problem. So we can say that if we place just the right amount of impedance at the end of the line for the amount of capacitance and inductance in each section of the line, then the amount of reflection can be minimized. Okay, and the reducing this reflection is desirable for the proper or reliable operation of that particular circuit. Okay, so what we are talking about, so this is this is the value of inductance and this is the value of capacitance. Okay, so the value of velocity of that traveling wave depends on the magnitude of this value, inductance and capacitance, and then when it reaches at the end, it will be reflected back. The traveling wave is going to be reflected back, and if we minimize those values, what we have to do, we have to place the right magnitude of impedance at the end of the transmission line. So this is basically what the traveling wave is, that how it will be generated. Okay, that we see that the traveling wave is generated due to the inherent property of each section having the amount of inductance and an average amount of capacitance, which is taking a time when we give the supply, and it will be reflected back towards the end. That's why traveling waves are occurred, and it is that traveling waves has also occurred. The main reason is we can say that there is a switching at the section, and if there is a lightning occurs on the transmission line, then also it happens the magnitude of traveling wave is going to be an undesirable way, or it could be increased in undesirable way. But this phenomenon, these things of traveling wave disturbance, we can minimize with the right amount of impedance is placed at the end of the transmission line. And how it happens, what are the parameters we have to consider, that we will be discussed. Okay, then now we moving further, we will see with the circuit with distributed constants. Okay, so we can see over here there is three kinds of transmission lines are there. There is a short transmission line, medium transmission line, and the long transmission line. Okay, and a transmission line is a combination of distributed parameters and circuit elements. Okay, that combination of distributed parameters, that means that it is having R, L and C in throughout this line. Okay, so we can say that in our we can say that the transmission line is with the distributed parameters. So exactly what is the distributed parameters, if we want to that particular meaning of the distributed parameters, that means we can define that distributed parameter means for per unit length. Okay, for particular per unit length, value of inductance is L1 and value of capacitance is C1. I hope you understand. I discuss about that distributed parameters. Okay, so what is the distributed parameters means? For the per unit length, you know that PU system, that is always considered when you are talking about this power system. Okay, that is the per unit system, that is the per unit system, which is established for the convenience of the better calculation for the power system parameters. Okay, so distributed parameter means that for the per unit length, value of inductance, that is L1, and value of capacitance, that is C1, throughout the transmission line. Okay, that is known as the distributed parameters. Okay, just a moment. Okay, so you understand what are the distributed parameters, and then if we moving forward for this particular statement, okay, these parameters are having the ability of, just a moment, okay, exactly, yes. So this sentence says that these parameters has ability to produce electromagnetic fields. Okay, these parameters means that distributed parameters, that is the inductance and the capacitance, okay, which is having the ability to produce electromagnetic fields. Okay, because whenever the supply is on, we know that it is having it is having the inherent property, that is inductance and capacitance, okay, which behaves in the way. Okay, so inductors and capacitance having the ability to produce electromagnetic fields, so that we know when switch S is on, that L1, which is having a charging capacity of 1.5 Li square. Okay, it is charged with this with this 1.5 Li square, and for the capacitance we can say that it is 1.5 Cv square. Okay, so inductance will produce the electromagnetic uh, electromagnetic energy, and the capacitor is produce the electrostatic energy when switch is closed, and at the beginning of that, when power is passed through that L and C. Okay, and we can see over here there is the generation side and there is the load side, and we consider over here it is the transmission line. Okay, so as per our discussion, that when a source try to transmit the power towards the load, it is not instantaneously reach at the load side because of that inherent property of inductance and capacitance. Okay, how and why, that we already discussed of it, that why it was not instantaneously towards the load. Okay, so we can understand it better with some of the example if we taken from here. Now here we consider a short circuit over here, a section of transmission line which is having an inductance and capacitance. Okay, so when supply S is on, at that particular time the L is behave like an open circuit and the C is behave like just like a short circuit. Okay, so this, whenever we turn on the supply switch S, this L, inductor L is behave like an open circuit, and capacitor C, that is behave like a short circuit at the beginning. Okay, so that what we stated over here. When switch is closed, L becomes open circuited and C becomes the short circuited. Here one picture is given for the better understanding the behavior of transmission line when generator or supply is connected towards it. Okay, there is a water tank. If we see, so we consider this water tank as our transmission line with the distributed parameters L and C. So what happens over here, the tank 1 is full and then the energy or that water is passed to the tank 2, and then when tank 2 is filled with this water, it will transmit it towards the end. Okay, so when this final stage reaches the power, when this 2 tank is filled of water. Okay, so similarly you can say that, so if I will give the supply to this ends, the first of all this inductor is going to be charged and capacitor is going to be charged with some certain value which is having one half Li square and one half Cv square. That what we discussed. Then this section is fully charged, that energy is transmitted towards this next section, and then the final section will get the power at end. There is a load is connected. Okay, so our transmission is behave like that. So during that, some of the wave is reflected back from that particular section, and this wave is known as a traveling wave, which increase the magnitude of voltage and which may be damage to our equipment which is connected to the transmission line. Okay, so in this lecture we just go through this basic discussion and understanding of traveling waves, how the transmission line behaves when we switch on the supply. Okay, in lecture 2 or session 2 we will discuss the detailed parameters, that is reflected waves, reflection waves. Okay, so what are the refracted wave, what are the reflection waves, what are the constants we have to consider when come into the picture. I will just give you some of the glimpse of it. Okay, so this diagram which is shows that there is a reflection and refraction is happens in our transmission line, and how it happens we will see that. So, okay, this is our transmission line with distributed parameters, which is having the effect of forward and backward nature of traveling waves. So if you can see that there is a number of section of transmission line over there. If suppose this is the transmission line T1, okay, which is having this source 1, when we give the supply, the power is travel through this line. Okay, it will reach at this particular point, and then some of the amount you can see it is going to be reflected when it's enter in the next section. It is going to be some of the amount is going to be reflected and some of the amount is going to be refracted over here. So this way this transmission line power is behave, some of the amount is refracted and some of the amount is reflected. How and what are the amount and what are the values of refraction and reflection, and how those constants are calculated with the transmission line open circuited and with the transmission line short circuited, and the parameters related it we will I told you as we'll discuss in the next lecture. So but basically it is known as a Beverly lattice diagram, which states the phenomenon of forward and backward nature of traveling waves. Okay, so I hope you understood with this explanation exactly what is the traveling waves and what are the worst effect of those traveling waves if we will not eliminate, okay, or if we are not minimize these effects of traveling waves on the transmission line. So main point of the discussion of today's lecture, that is what are the traveling waves, okay, how it will occurs, that we will see traveling waves occurs due to the inherent parameter of inductance and capacitance when switch supply S is on, okay, and it will double the magnitude of voltage uh, when it reached up to the load. How it will be eliminated, that we will see. I will just give you one example. If in every substation this transmission line is terminated through the cable, it is very important word, that is it is terminated through the cable, okay, to reduce the effect or minimize the effect of this transmission line. If we are not terminate it with the cable, it may be damage to our equipment which is connected to the power system, okay. So I hope you understand what is the traveling wave, what are the worst effect of traveling wave if we don't minimize this traveling wave from the power system, okay. Thank you. Okay, and one more thing, that okay, so finally this kind of question asked in a GTU, that we see that there is an explanation, they are asked for the explain reflection and refraction of traveling waves by considering voltage and current waves, and write down the expression for reflection and coefficient and reflection coefficient and refraction coefficient, okay. And another question is that there is the explain effect of source impedance on the switching operation of transmission line when the end of the line is short circuited, okay. So there are two things that has to be discussed, that is line is short circuited and line is open circuited, which is having two different parameters and coefficients when the line is short circuited and when line is open circuited, okay. So such kind of question asked in GTU examination, and you can see it is repeatedly asked question throughout from the 2015. It has asked each and every time for GTU examination. So it is very important question and answer that you have to be prepared for your examinations, okay. Okay then, thank you.